Rightio, g'day students. We're going to be talking about sketching linear graphs again today. So this is our second lesson on linear graphs. And the point of today's lesson is to really determine the intercepts of a straight line graph from both its equation and its plot using the linear formula y equals a plus bx. And then we want to interpret in context the slope and intercept of a straight line graph used to model and analyze a practical situation, and then also construct and analyze a straight line graph to model a given linear relationship, such as modeling the cost of filling a fuel tank of a car against the number of litres of petrol required. So let's familiarize ourselves with the linear equation again, which is y equals a plus bx. And so when y equals 0, so that's this point along here, or this number here, so when that equals 0, we're going to be able to find our x-intercept. So in this equation, it's going to be -2. So our x-intercept equals -2. Now our y-intercept is up here where the graph crosses the y-axis, and so that's going to be +2 here. So we've got a +2 and a -2. And we can also recall the gradient, remember, which is rise over run. In this case, we're going up 1, going up 2. For every 1, 2 we go across. So it's rise 2 over 2 equals 1. When we have a look at the linear equation, y equals a plus bx, remember that the a part is the y-intercept where it crosses the y-axis, and a here equals the x-intercept, so that's where it's crossing the x-axis, and b is a gradient. So we're just going to substitute in those numbers we looked at last slide, and we're going to just put that into our formula. So the equation of this line is 2 equals -2 plus 1x. So recall that the gradient here is 1, so we're going up 2 and across 2. So that's got to equal a gradient of 1. Our y-intercept is where it's crossing the y-axis. Our x-intercept is where it's crossing the x-axis. And so you can see that we can just substitute these into the equation. So that's got to go there, that one's got to go there, and that one's got to go there from reading this line. So back to our phone call question. So remember the question is that the cost of a 5-minute phone call was $3. Now if the connection fee was $1, what was the cost per minute? And we said, well, the linear equation is the cost equals 1 plus the rate per minute times the number of minutes. And we said, well, x is the rate per minute. You'll also notice that that is the gradient, isn't it? So we're going up 1, and then we're going across 0.4. So if we have a look here, we're going to just use that to find our intercepts, and that's the point of this part of the lesson. So we've got our y-intercept, and you notice that if I continue that down, that should indeed intercept the line at $1. And it also makes sense. If a connection fee is $1 as soon as you pick up, that's going to be where the start of the cost. Now to find the x-intercept, we just need to let y equals 0 in this equation. So you can see that it's y equals 1 plus 5x. So to find the x-intercept, we turn y into 0. So that means we're going to be reading on this line somewhere, and it's going to be hitting down here. And we can rearrange that formula. So 0 equals 1 plus 5x. So we just move that plus 1 to the other side of the equation with inverse operation. So -1 equals 5x, and then we need to divide both sides by 5. So -1/5 is the same as 0.2 in that case, I should reckon. So I wonder what's happened there. And that's where it should cross the line. So when we want to move from a linear graph to a linear equation, we just need to recognize where that graph hits the axes. So remember that this is our y-intercept, this is our x-intercept. We then put those intercepts, so our y-intercept is positive 3, so that's our y-intercept, plus 3 there, and x here is this one here is our x-intercept, so it goes here. And last of all, we can talk about the gradient too, so you can see that for every, we're going rise over run, remember, so in this case we are going down 2 and then across 1, so it's going to be a gradient of -2, and that's what I've written here, -2x. So we've got plus 3 and now a -1.5, yeah, that makes sense, and a -2. Now we can also predict the outcomes of these linear functions or these linear relationships by two different ways. We can do it from a graph, or we can do it from the linear equation. We'll have a look at the graph first of all. So from the graph, all we need to do once we've written the graph is just to extend the line until x equals 4. So we just need to continue it along down here, and then we'll read the coordinate. In that case, when x equals 4, y will equal 5, or -5 I should say. We can also do it from the equation, and so all we want to do is, for example, substitute the value into the equation and then solve algebraically. So in this case, when x equals 4, all we're doing is putting in the x value for 4. So y equals 3 take 2 times 4, which is 3 take 8. 3 take 8 is -5. So we also have our x and y values of 4 and 5. And you can see that we can get it both from the graph and from the equation. So that's a very important way to evaluate and verify your work. Now, if we want to sketch a graph from just the intercepts, so all we're doing here is 2 points at the moment. So we've got our equation written a little bit differently here. We said 3x plus 2y equals 10. So you can see I've just put the x and the y values on one side of the equation and the constant on the other. So all we need to do is rearrange that algebraically. So you can see here that I've taken the 3x and I've moved it over. So I've just minus 3x from both sides. So 2y is now 10 take 3x. And I can divide both sides by 2, so that means y equals 10 over 2, or 5, take away 3 over 2x. And so we can find our x-intercept of 5, and we can also just head back up to the top and solve for x, letting y equal 0. So 3 times something plus 2 times 0 equals 10. So we should know that x will equal 10 divided by 3, which is 3 1/3. So now we have our two sets of coordinates. We want to construct a linear graph, and we've got our x coordinates. So we've got 3, let's try a bit better color, 3.33 reoccurring for our x value, and our y value is 5. So we want to construct a graph, and you'll notice that we're in quadrant 1, so the plus, so we're over here. We're not worrying about any of these. And we'll want to write in the scale. So I'm trying to fill up the space as best as I can. 1, 2, 3, 4, 5, 6, 7. So I've got 7 spaces now. I reckon I could get away with calling that a 1, calling that a 2, calling that a 3, and we'll just fit that in. So every 2 squares is equal to the value of 1, and that bit there will be 3.5. So that will fit the space, and then if I'm counting up 1, 2, 3, 4, 5, I will have to just use 1 square is equal to 1. So there we go, 1, 2, 3, 4, and 5, and then we're just going to put in our x and our y intercepts. So our x-intercept is where it crosses the x-axis. Our y-intercept is where it crosses the y-axis. And I'm going to try and draw a straight line with my pen, but I'd recommend using a ruler, of course. And there we have our line there for our linear equation. Now we can also use linear equations or linear graphs to represent real life situations. So for example, if we're looking at fuel efficiency, I'm particularly interested in the amount of money it takes for me to fill my petrol tank. So I was researching about the efficiency of E10 fuel as opposed to normal unleaded. So I was reading this article about 3 Camrys, and their 70-litre tank came out at an economy rate of 9.81 litres per 100 kilometres for E10. I thought, okay, so let's work this out. How far should this go on 1 tank of fuel? So all we need to do is to substitute that into our linear equation, and we can graph that. So what y would be the distance? A, well, we start off at a 0 distance, at a 0 fuel consumption, so that's just going to be 0, but B is going to be 9.81 litres per kilometre. And so find y, then we're just going to multiply that 9.81 by 70 litres, and that should get us to 686.7 kilometres. Now if I'm looking at this graph, I'm going to have litres down the bottom. I'm going to have a range, as in the distance could be travelled, so in kilometres up here. And then I can graph that using the y-intercept and the x-intercept of 70. So there we are. On the y-axis we've got 686 kilometres, and on the x-axis we've got 70 litres, and then we can just draw a line to graph that. So we can draw the linear graph just from the x and the y-intercept. You can of course use the gradient, which is also going to be the rate of 9.81 litres per kilometre. Now we can also calculate PAYG tax and express that as a linear equation. But we're going to have to do that for each tax bracket, because you can see that we have a variety of different rates here. And so we've got like a 32% rate, a 37% rate, and a 45% rate. So back to Seymour Bucks from lesson 3, he earned 72,000 or thereabouts a year per gross, and we want to see how much Seymour pays for tax. So we can complete the equation. So we're looking at this tax bracket here that I've circled. So it's just 3,572. Well, that looks like an intercept, doesn't it? And we can then just calculate the rest. So it's 32% times 72,546 minus the bottom of the bracket. And that will give us a total tax of $15,124.45. So I can express that here. So here's the bottom of the tax bracket. Here's what Seymour is paying in tax, and then I can just graph that. And you can see that anywhere here. So if someone's earning 55,000, I can just read across and go, oh, okay, they'll be earning, they'll have to pay about $9,800 tax. So that's quite easy to manipulate there. Coming in at a little bit more complex is graphing all of those rates at a different amount. So I just went to a spreadsheet, so Microsoft Excel, and I calculated the tax for each at the top of the tax bracket. So you can see my data table here. So I just said, okay, if I'm earning 0, I'm paying 0 tax. In fact, if I'm earning $18,000, I'm paying no tax at all, really. So if I'm going to translate that into the linear equation, I've expressed this here in Microsoft Excel. So I said, oh, well, 19% multiplied by every dollar over $18,000. And 18,200 is the new one. So I should fix that up there. And then we just plus the B3. So plus B3 in this case was $0. If I wanted to look at the next tax bracket, which was for Seymour Bucks, he had what, 72,000. So he could we could work that out by putting 72 in there, and it would calculate the tax. Otherwise, we could just see the read off the graph as well. Now, what's also interesting is you can see that there's no tax for the first $18,000. Then the slope is flatter, and then it gets a bit steeper, and then steeper again, and then steeper again. And so you can see that there is an increasing gradient for each of these tax brackets as well. You may want to have a go at this in Excel. I'll probably get you to do this in class as well. So finally, are you able to determine the slope and the intercepts of a straight line graph from both its equation and plot its y equals ax plus bx? Can you interpret in context the slope and the intercept of a straight line graph, use to model and analyse a practical situation? And can you construct and analyse a straight line graph to model a given linear relationship? For example, filling the fuel tank of a car. When you are confident about that, I'd like you to practice some mastery and choose that in these exercises down below.